and then we are going to use, and then this is given to output, which is output layers or data prediction layer, and then finally it will tell like which layers it give output. Let's say linear layer, right? So this is what we are going to talk, right? And let's talk about this one. So this is the example. Input go here. Okay, so hidden layers, and now the next layers is activation layers and output layers and so on, right? Okay, let's talk about this one. And so introduction, neural network architecture. This is architecture, right? Input layer, hidden layer, and output layer. And this is the weight and bias and activation function. And so input layer, here you see the green represent the input feature. Hidden layers is the applies weight and bias. It's basically hidden layer is weight and bias followed by activation function. Output layers is this layer, blue dots, produce the final prediction and classification, weight, bias, and activation. These are very important things function. So I'm going to give one example of SAT and GPA. So how this will achieve, I have end of the so this is what target we are going to reach, like set score, HS score, and the based on that we need to score the target. This example, it's a high level, but I'm not going through this example. So this is sum. So how we are going to do sum of set score, sum of HS GPA. So we are going to transfer here and set I1, I2, and similarly GPA I1, two input parameter, set 1 and I2 HS GPA, two neurons, right? Hidden layer is H1 and H12, which activation function, H21, single neurons, output layer a single neuron, and FY, this is the, so this is input, and then weight W1, W12, W21. This will go here, W11, W12 is will go, W21 is go here, W22 is go here, and then this is output layer, right? Now this is hidden layer. So connection, total connection 4, nodes is 4, bias is 4, right? 4 plus 2 is, yeah. So this is how we do, and 6 dependent parameter plus 3 new parameters. 9 dependent parameter it is. So how it will connection, how many connections? So 1 2 3 4, 2 and 2 connection, 4 connection. Nodes, nodes is this one, 1 and 2, 2 nodes. Bias 1 2 3 4 plus 2, right? So 6 dependent parameter W1. So this is what we showing the calculation. 6 dependent parameter per 3 new parameters. So 3 new parameter, I think they consider 1 2 3. So total 9 parameter, right? So calculate weighted sum into input. Identity matrix 1B, B1, B2, and W1, W12, W2 is W21, W3 W will become this one, and apply activation function. Sigmoid function we are going to use. Sigmoid function, this is we are going to use, and output act input of the next layer. Yeah, that's correct. Like this is input, and this is output with the next layer, right? Sigmoid O1 and sigmoid O2. O2 is output layer, right? So O1, O2. So when we talk about O1, then it's W1, W21 into I1, W1 into I1, W2, I2 into W2 plus bias. There is a bias. And O2, so if you, this is O2, it's still coming from this 2 layer. So this layer is W12 into I1. Similarly, it's coming from here, W2 into I2 plus bias. Calculate weightage. So this is the formula, right? The formula is W score into X something, right? So here W score to 1, W2 score W21 is W21. This one is W21 into O1, W2 score into O2 plus bias B2. So apply activation function. So activation function is W2 score to 1, O1, W2 score, 2, O2. So O1, O2 is we came from previous layers. So each output is layer of the next layer. This is activation. So activation function of last layer. So there is a activation function can be like linear activation function or ReLU. Regression problem with negative outputs use this one. For example, temperature prediction. Okay, regression problem with positive output is house price. So there is a two ReLU is used for this one, linear activation used for this one, right? And here we are sigmoid used binary classification, softmax used for multi-classification problem. Okay, and this is activation function which is house price. Now I'm going to talk about various activation functions in the detail. In my previous lecture already I talked, so I'm going to talk about linear activation function. So linear activation function can be both positive and negative, right? So linear, let me talk about linear. So linear is nothing but linear, it can be positive, it can be negative, right? Positive, negative. So if you see the example of positive and negative, there may be temperature. Some countries can go to negative, like Russia. Some country have forward. So when you want to predict temperature, we can use linear regression, right? Linear activation function. Okay. Now let's talk about ReLU function, right? ReLU is nothing but rectified. It's rectified is next level. Rectified linear unit. This is ReLU full form, right? So this is used for problem where output is always non-positive. So always non-negative, non-negative, non-negative means positive. So example, housing price cannot be negative, right? So wherever you want to find housing price, you can use this one. Now some classification function. Classification means you want to find like this is dog, this is cat, this is camel, this is deer or something like that, right? So okay, there may be many. So for this one we use a function called sigmoid. This is used for sigmoid. This is basically use binary classification, predict 0 and 1. Okay, so sorry, sigmoid is used for binary classification. Okay, so that means 0 and 1. So where we use 0 and 1, so for example, you got email and you want to check whether it's spam or not spam. So this is 0 and sigmoid function, right? And sigmoid function equal to 1, usually 1 divided by 1 plus e power minus g or something, right? Usually this one in I read in my mathematics. This is used for this one, right? Now Softmax function is used for multi-classification. So this sigmoid is classification, again 0 and 1, but multi-classification. Multi means previously I gave example like cat, dogs, birds. Sorry, dogs is spelling wrong. Birds, birds. So this one we use Softmax. It's the next level, and an image classification and so on. So this is what we are doing. So now in this lecture I'm going one. So this is what I give: temperature prediction, house prediction, spam detection, image. You can go through this. Now I'm going to one example. For input is set score, HS GPA, okay, and then hidden layer is neuron 1, 2, 3, 4. Then we use ReLU. So now ReLU is used where? Just now I said in example, ReLU is positive. So right, they cannot have negative number, right? So we use ReLU here. Now, okay, this is example. This is code I have written, and this code we have everything, and this is the output. Okay, So the program start from here main, and then it will go to the main. Creating datasets is create datasets, then prepare datasets. Prepare is the datasets is called the prepare dataset. Then creating train model, it will create models. Train visualize is a visualize model, and the print sample prediction, actual GPA and predicted GPA. So actual GPA is 2, predicted 0.2. Actual GPA 2, predicted this one. Actually 2 point, so it's a negative. I think this is some problem here. We need to see predict college GPA is 0.48. GPA we are expecting. So this is how, but you guys go through this example I have created here. Okay, so let me show you guys. This is how where I read. Sorry. Okay, sorry. Okay, I want to put into. Give me one moment. Full screen. Okay, so let's go through this neural network example. It will go to here main, and the creating datasets. Create datasets is here. We are random number. We are set scores random number, location 12, scale up to 150. Number of student is hundreds. Okay, and similarly we are doing, basically it's nothing, it's generating data. So if you want to see this data, we can see data here. Let's go to here main, and then here df.create dataset. So we can print data here, df.print add. Okay, let's see. We are going to write. So let's start this program. So this is how the set score. Okay. In my previous lecture, I think we didn't get code because I used from different computer, but now we got GPA score 1.47. So which is correct, quite correct. Let me put there here. I think this is more correct way, right? And this is Python outputs. I think auto. Let's see. So activation function play a crucial role in guiding neural network towards machine learning. They will help neural network to enabling accurate prediction. Okay, so you guys, I'm giving my GitHub links. So guys, please check, watch it out. Okay, I put here, and you can go through the GitHub links and see the deep learning problem. And this is what I put here, my code. Okay, thank you for